It's the Vaadin data model. So as I said, this is subject to change in Vaadin 8, but it's a change for good. It's going to be simplified a lot. Still in the current release of Vaadin, you can use it, and it's really good. It's really flexible, which is what I like. So there you have it. This is a picture of the Vaadin 7 data model: a property, an item, and a container. 3 parts. Property is the simplest one. It's a typed value. So some object and some type of that object together, they form a property. An item is a set of uniquely identified properties. So each property within an item has its name, or as it is in the model, it's an identifier. So it doesn't have to be a string. In 99.99% of the cases, you want to use strings as identifiers of your properties, but the Vaadin data model does not force you to do so. And then the third step is the container. So now we have a set of uniquely identified items. So you can see the mental relation to the database table in relational database. A container is a table, an item would be a single row, and then a property would be a column, a value from a column and its type. Few characteristics about the Vaadin data model. First of all, these are all interfaces. So there is no implementation per se in item, property, or container. The model itself has no implementation. There is implementation in the framework, of course, so that you can use some data sources. But the plus side is that you can implement anything and it will work with the Vaadin Framework components. So whatever data model you have, if you just implement access to it through container, item, and property, you can use any Vaadin components and it will work. There is a built-in support for events, and this is done the Vaadin way. So the components, when you assign them a data source, they check if the data source implements certain interfaces, and if it does, then they will subscribe to events. If they don't, well, then it won't. And then there is some type safety. So there are generics in few places, and there are validators. And of course, it's very, very easy to extend that. You can now a few words about what is there in the framework with respect to the Vaadin data model. So first of all, as I said, is the property, and it's generic. And then it has events when it changes. So value change event is what is going to happen if you implement, of course, value change notifier. The type of a property cannot be modified on runtime, and you can, of course, use it to typecast the value if you lose the generics somewhere in the process. What is optional in the property is that you can set the property as read-only. So this has the same effect as the components that I was talking about, or as the field I was talking about last week. Read-only means that you cannot change the value, and if you try to do so, you will get an exception. And the reason why this behavior is similar is that all fields, they actually implement a property interface. So they are properties in themselves. You can use one component, one field, as an input to another component. What is more, you can have a transactional property, which is a support for buffering, more or less. It's like an internal cache. Then there are two functional interfaces. They are for your information as a user of the code, a property viewer, and then the next one is a property editor, which both have exactly the same methods. But it's the intention or intended use of the component that matters. So if you have a property viewer, then you would assume it will not modify the property. It will just use it to display it. Whereas in the property editor, you can assume that the class will actually modify the property, or this is something you can modify the property with. Now the next step is an item. It's a set of properties which are unique in one item. The identifier can be any object, and if you're implementing your own item, please make sure that you're using some order-preserving collection. So a list, for example, would be good. There is an optional support for adding and removing properties, and the generics of properties are lost. So once you get a property from an item, then you have to get its value and typecast. And similarly, as with property, we have item viewer and item editor. They are supposed to be used in components or objects. A field group is something I will talk about in a few minutes, is something that has both of these methods, but it's not implementing the interface for an unknown reason, and it continues to do so for many years. Finally, a container. So it's a set of items which basically does not guarantee you any item order. It enforces that the identifiers of items are unique. And the identifier can be any object again. The container places some constraints on the items it contains. There must be the same number of properties in each of the item, and they all have to be the same. So they have to have the same identifier and the same type. And then there is lots of optional functionality. The container allows you to obtain and query the items. And this method right here, which is called getItemIDs, it can be time consuming. You can optionally add removing or adding new items. And then basically the same stuff that you can do with items, you can do with properties. You can get container property IDs, you can get the type of each property and so on. And then optionally you can add or remove properties there. And if the container supports that, then this property will be added to all the items it contains as well. This is the visual of what I just said previously. You can see the container here up. These are the features. So there is ordered, indexed, filterable, sortable, hierarchical. I will explain those in a few minutes. Container contains items. Items contain properties. And then a field is an implementation of a property. So that's why you get all the benefits of a property inside a Vaadin field. Again, container viewer and container editor. This is like showing you an intended use of a component. All selects are viewers, so they give you an options to choose from based on the data source that you have. So an ordered container, this is like the first of extra features that you have in a container. As I said previously, by default, a container interface does not guarantee any order of the items. Ordered gives just that. It allows you to traverse through the items from first to the last. The next step is that you have an indexed container. So now each item is associated not only with its ID, but also with a non-negative index. And you can get items by index, or you can find an index of an ID. Then once we have an order and we have indices, then we can sort a container, which is slightly more than an ordered container. You can call sort here a method which takes an array of objects and an array of booleans. So these are the property identifiers, and this is whether they are ascending or descending. Adding items to a sortable container is complicated because it may depend on the sorting. Once we have a container, we can also filter it. So filterable container, there is an interface called filter, as you can imagine, which you can add to a filterable container, and it reduces the number of items that are currently visible on the client side or in the component itself. Again, adding items is optional and quite complicated because the item you add might actually be removed by the filter. And if you ever need more, then you can implement hierarchical container, which gives you parent-child relationship between the items. It's very similar to a typical tree structure, with the exception that you can have many root elements. Here on the last bullet point, it says that sorting, ordering, and indexing is complicated, and it is because it's kind of hard to define an order for a tree-like structure. The framework itself has a bunch of utilities that you can use. The most straightforward implementation of property is object property, and it broadcasts events. You can also bind a property to a setter-getter pair. So if you need something else, you can extend from abstract property, which is good in a sense that it handles all the listeners, so it maintains the list of value change listeners, but it does not fire events, so you have to do that yourself once you change the value. One step up, we have items. The most common use is a bin item. And then once you have a bin item, you can put it in a container. So a bin item container is a container for beans. It's an in-memory container. You can get the item IDs, which are beans actually. As it says somewhere here, yes, it uses beans as identifiers. So an object that you place, it's its own identifier. And then, of course, you can get an item, an implementation of an item interface when you call getItem. What is required is that you have a meaningful hash code in your class. So hash code and equals have to be implemented. What is good is that bin item container is filterable, indexed, ordered, and sortable. So the drawback, which is imposed by the Java language, is that you, of course, cannot add or remove properties. Slight variation of bin item container is a bin container, which uses an ID. If you want to implement your own stuff, there is a class called abstract in-memory container, which is an abstract in-memory container. So it provides few things for you, and then you can just focus on implementing the rest. If you ever encounter a container that does not give you certain properties that you would like it to have, you can use wrappers. So there are a few wrappers that add hierarchy or order to otherwise non-ordered container, for example. And this is, at least to me, a source of confusion. Certain UI components, they use wrappers internally. And rule of thumb, if you're implementing your own container, then please implement as much as possible. We have indexed container, which is a reference implementation of a container interface. It just stores items. It's an in-memory container. So you can have any item ID, any property ID, whatnots. There is one subclass in the framework. It's called hierarchical container. Then real stuff. So if you want to connect your application to an SQL database, you can use SQL container. It works in two modes. A table mode is the default one. You can just fetch the data almost automatically. Or you can use free queries, which requires you to implement some SQL specific stuff, but then it gives you a bit more flexibility in what you do. And I have to say that there is quite an impressive list of limitations of what you cannot do with an SQL container. Then, if you're not happy with that, you can use a JPA container, which is a free add-on, and it's a container for Java Persistence API. There is support for basically everything that you would like there to be. So lazy loading, filtering, nested properties, whatnots. The advantage is that once you manage to use that add-on, is that you get out-of-the-box CRUD. And this is using an object relational mapping. Okay, well, we have the property item container. We have a container that connects to a data. Field binding, we have to do something with that data. We have to bind it to the components. And here is where we have a field group. A field group is not a component. It does not manage any layout. You cannot add it to anything. What it does is that it binds or builds fields based on an interface called field group field factory, which based on the type of a field creates a component that will be displayed. And it does all the magic behind the scenes. So it binds it to a property in the underlying data source. There is a default field group field factory, which is one of the most ridiculous class names I have ever encountered. But it does its job quite well. So the field is a component for a property. Most components are field, as I said. This is a property, what I mentioned previously, so it broadcasts value change events. What is good is that you can mark a field a required one. What you can do also with a field is that you can buffer or validate it. Buffering is storing the change that the user has entered locally until they commit it. Commit and discard are obvious in this context. And then the validation. This is very important in the terms of usability of your application. Most often you want your data to be valid, and you define what it means to be valid. Vaadin gives you a validator interface, contains one method called validate, and then you can just check if the data that the user has entered in the field is okay or not. Optionally, you can allow the field to have an invalid value, but I see absolutely no reason to do that. A very important thing is that there are a few implementations of validator in the framework. So there is an email validator, for example. There is a non-null string validator, and so range validator for numbers, and so on and so on. Now there should be a demo, but as I'm running out of time, I just recommend you to take a look at GitHub on the branch step 4. We're adding a container for messages. And I'm using a trick here. The container is an in-memory container, which is static, which makes it shared across the virtual machine. So all the instances of our application, or all the users, they connect to the same data source. And what happens here is that we are using push. Whenever an event happens, we are modifying the UI, and then we are pushing it to the client. And that's it for today. Hopefully you got a glimpse of the Vaadin data model. What are the key elements and how do we link them to components? Events, I hope you know how to catch the events and the different types there are. And then how to display annoying pop-ups to the user with notification and window. And then something that I didn't show but I told about is the push. Well, let's see if I can maybe just check out the code. Oh, there you see it. Message changed. This is an event that we're capturing in the container. We access the UI. This is the magical thing that we have to do. So a new runnable which modifies the layout by adding a component there, and then it pushes the stuff to the client. And the only requirement is that we have a push annotation on our UI. And the mode is manual, which means that we are explicitly invoking it by calling push.